Good morning, fifth grade students. This is Ms. Jagodnik bringing you your math lesson for today. Just like the last couple days, we're going to be focusing on converting units of measurement. But instead of focusing on length or capacity, today we're going to talk about weight. As you should have already seen in your book, there are only 3 units of weight we really need to worry about. The smallest unit is ounces. Then we can convert to pounds from there, which is what we usually weigh ourselves in. Or if we're talking about weighing something really large, like an elephant or a truck or a building, we could talk about tons. These are the measurements you need to remember. It takes 16 ounces to make a pound, and it takes 2,000 pounds to make a ton. Just like with length and with capacity, we need to think about when we're converting. Am I going from a little unit like ounces to a bigger unit? Or am I starting with a bigger unit like tons and going to a smaller unit? Remember, it takes a lot of small units to weigh the same thing. It would take only a few big units to weigh. So if I am going from a smaller unit like ounces and going larger to pounds or to tons, then I need to divide, because my answer should be a smaller number. If I'm weighing an elephant, it's going to take a lot of ounces to weigh that elephant, but it's only going to take a few tons. If I'm going from a big unit like tons down to a smaller unit, then I'm going to need a lot more of them. So I need to multiply to get myself a bigger answer. So remember, if I'm going from smaller to bigger, I divide. If I'm going from bigger to smaller, I multiply, just like the last couple days. Let's try a couple of the problems in the book that might be a little trickier because they don't work out evenly. So if you're following along in your book on the classwork pages, we're going to start with number 5. Number 5 asks you to convert 6,500 pounds into tons. So remember, I'm going from pounds to tons. I'm starting with a smaller unit, going to a bigger unit. So my answer should be smaller. I won't need as many tons as I need pounds. So I'm going to be dividing. And I'm going to be dividing by 2,000 because that's my conversion. So to go from 6,500 pounds into tons, I need to do 6,500 divided into groups of 2,000. Okay. Well, gee, I know that it takes 3 2,000s, 2,000, 4,000, 6,000. Okay. That's as many as I can make. After that, it would be 8,000, and that's too big. Okay. So when I do 3 groups of 2,000, that means I can make 3 whole tons out of 6,500 pounds. But I still have 500 pounds left over. That's not enough to make another ton. That's my remainder. Okay. As we talked about a couple days ago, I don't want to use a remainder. I want to convert that into tons as well, but it's not going to be a whole ton. So I want to think about what fraction of a ton is that going to be equal to. So 500 out of 2,000 pounds it would take to make a ton. 500 out of 2,000. That does not look like it's in simplest form. Well, let's see. I could get rid of 100 I could divide by 100 in the numerator and 100 in the denominator, and I come out with 5 over 20. 5/20 is still not in simplest form. I could divide that by 5 over 5, and that's going to come out to 1/4. So that looks like its simplest form. That means out of 6,500 pounds, I can make 3 whole tons, and then 500 pounds in the next ton, that is 1/4 of the next ton. So 6,500 pounds is equivalent to 3 1/4 tons. Okay. Now I want to do number 10, because number 10 is very similar. It's just going the opposite way. So I'm starting with 7 1/10 tons. I want to convert that into pounds. Gee, that's a smaller unit. I'm going to need more of them. So this time I'm still going to be using my 2,000, but I'm going to multiply. So I can start by taking my whole number and do 7 times 2,000. That's going to give me 14,000 pounds. There are 14,000 pounds in these 7 tons. But I still have a little bit extra. I have 1/10 of a ton. Okay. So what is 1/10 of 2,000 pounds? Oh, well, that would be easy because that's the same as doing 2,000 divided by 10. And we know that 2,000 divided by 10 just means that we're changing place value and we're moving the decimal point over one place. So 2,000 divided by 10, taking off that extra 0 is 200. Okay. So 7 tons is equivalent to 14,000 pounds, and this extra 1/10 of a ton is equivalent to an extra 200 pounds. 14,000 plus 200, that means my final answer is 14,200 pounds. So 7 1/10 tons is equivalent to 14,200 pounds. You can see all of that there? Okay. Now going on to number 12. Number 12, we are working with ounces and pounds. Okay. I am starting with 4 ounces, and I'm trying to convert ounces into pounds. Well, gee, now I'm starting with a little unit, ounces, and trying to change it into a bigger unit, pounds. I'm not going to need as many pounds, so I'm definitely going to be dividing. It takes 16 ounces to make a pound. So I'm going to take my 4 ounces and divide by 16. Oh no, that's one of those problems where the dividend, that first number, is smaller than the divisor. Now we know what that means. That means that my answer is going to be less than 1. Let me think about if that's reasonable. Yes, I guess that does make sense because we're only starting with 4 ounces. If it takes 16 ounces to make a pound and I only have 4 ounces, then I'm not even going to be able to make 1 pound. So it does make sense that my answer would be less than 1. I'm going to end up with a fraction. So let me see how to divide 4 by 16. Well, gee, that's the same. Division is the same as fractions, right? So 4 divided by 16 is the same as saying I have 4/16 of a pound. I can divide my numerator and denominator by 4 and put that in simplest form, okay? 4 ounces is equal to 1/4 of a pound, okay? All right, we're gonna change it up now. This next problem has nothing to do with converting units of measurement and weight. But when I was looking over the class pages, I realized that this problem is pretty tricky. And I know that one thing that my class has really had to practice a lot this year is perimeter and area. And that is a kind of measurement. So I wanted to take a minute to go over this problem just in case when you were trying it on your own, you had a hard time with it. So if we take a look at this problem, number 20. Number 20 gives you the perimeter of a rectangle is 160 feet. And it asks you to find the area. So I want to take a minute to remind myself of my formulas here. Perimeter is all of the sides of a shape added together to get the total distance around the shape. So if I'm talking about a rectangle, I'm talking about 4 sides. I have to add together length plus width plus length plus width. I'm starting to see my problem that I only have one side labeled and I need to add together 4 sides to get the perimeter. But then they also asked me to find area. Okay. Area is length times width. And again, I only have one number here. So how am I going to find the area if I need to do length times width and all I know is this one dimension is 50 feet? Seems like first I need to find the other dimension. How can I find the other dimension? Well, the other piece of information they gave me was the perimeter. So I must have a way to use the perimeter to help me find the other dimension. And then second step, I can find the area. So let me think about how I can find that other dimension using perimeter. I know this must also be 50 because it's a rectangle. So this must also be 50 feet. But I still don't know what this side is. Oh, but I know the whole perimeter is 160. So I must have 50 plus 50. That's 100. Okay. Plus this side plus this side equals 160. Okay. Well, gee, that must mean that this part is 60. Okay. Because if this plus this is 100, and this, I'm going to get 160. I'm still missing 60. These two together must be 60. And since this is a rectangle, I know they have to be the same thing. So how can I get to 60 putting two of the same thing together? Gee, it must be 30 plus 30. Oh, so now I found the other dimension. 30 and 30 units are feet. Great. Okay, so now I know my rectangle is 50 feet by 30 feet. Can I find the area now? Oh, yes, I can, because now I know the length and the width, which is my formula for area. So to get the area, I can do 50 times 30. Oh, that's easy, because I'm really using my base fact, 5 times 3 as 15, and then I am annexing my 2 zeros. So it looks like my number is 1,500. Let me think about the unit. This is area. I know area units are always square units because I did feet times feet. This must be square feet. So my final answer here, the area is going to be 1,500 square feet. Remember, we use that exponent 2 to show the unit when it's a square unit. So my final answer is area 1,500 square feet. Okay, I hope this demonstration helped you. If you have not already done so, go into your Practice Buddy and do the homework pages and make sure you hit turn in or submit or whatever the phrase is online so that your teacher gets your results. Okay, I'll see you again in a couple days.